Okay, so we need to know two equations for part 2. The first one is the tension equals the lambda over the natural length times the length. The final one times the minus the natural length. And the second one is tension equals the mass times omega squared r, which is equal to mass times speed squared over r. You also need to know net F. The net F equals ma. So for basic question 1, they gave you a string of length 1.5 meters. They also gave you modulus 15 Newton of the string. It has a mass attached to it at one end, which is 12 grams, and the other end is 6, and it executes in uniform circular motion. They want you to find the radius. They also gave you omega to be 5. So from the first equation you can get d equals 15. This is the lambda over the natural length 1.5 times the length minus 1.5 the natural length. And from the second equation you can get d equals the mass times omega squared r. The mass in kilogram is 0.012, and the mass omega is 5 squared times r. And then you equate them. So it's 15 over 1.5 times the length minus 1.5. It's equal to 0.012 times 5 squared times r. R and L are equal. R is equal to L. And you're supposed to get 1.546. So for basic question 2, you have a string fixed to a point O, and at the other end you have the mass m. It's traveling in a horizontal circle, and this point O, it's 0.6 meters above the center of the circle. The length of the string is also 1 meter. This mass is 3 kilogram. They want you to find the tension and the v, the speed. You also have mg on the mass and tension like this, and this is the radius. So we can draw like the triangle of the forces. This is the mass, this is the point O, this is 1 meter, 0.6, this is the center of the circle. Tension is acting like this, mg, this, and you're supposed to have the circle like this. So we can resolve the tension first. This is the tension for along the y, and this is tension along x. You also have this alpha, which is the same as this one, and here you need cosine alpha. Cosine alpha is adjacent over hypotenuse, which is 0.6 over 1. So from here you can use net Fy equals 0. So the tension times cosine alpha is equal to mg. The tension will become mg over cosine alpha, which is 30 over 0.6. That will give you 50. Now for part B, they want you to find the v, which is the speed. You can use one of the equations from before, which is t equals mv squared over r. Now for r, we have to refer to the triangle again. This is 1, this 0.6. Using Pythagorean theorem, you'll get this is 0.8. So now we can, this is supposed to be also t sine alpha. So t times 0.8 is equal to 3v squared over 0.8. then you'll get 50 times 0.8 is 3 times v squared over 0.8. You will get v to be 3.23 meter per second. For number 3, you have an inextensible string, length 0.6 meter. One end is attached to a point O and the other end is a mass m, which is 0.8 kilograms. They also give you the frequency equals 36 revolution per minute. And that's all they gave you. They want you to find the tension. First of all, we convert the frequency to revolution per second, so you multiply 36 by 1 over 60, you'll get 0.6. Then you have the equation. The frequency is the angular speed over 2 pi, so you'll get the angular speed is 0.6 multiplied by 2 pi, which is 1.2 pi. So after that, you use T equals the mass times omega squared r, which is 0.8 kilogram. We got omega to be 1.2 pi squared, and we have r to be 0.6. You'll get 6.82 newtons. Okay, so for number 4, you have a disk which is rotating. Its radius is 0.1 meter, and you have a particle on its edge, which not tension is preventing it from falling. In this case, it's friction. So we use the normal equation, but friction replaces tension. They also gave us the mass to be 0.5 kilogram. They also gave us mu, which is 0.25, and we need to find the angular speed. So to find friction, we need to find the normal push, which is from here, it's like this. Net Fy equals 0, n minus mg equals 0, n is mg, which is 5 times, no, 0.5 times 10, so it's 5. And then you can find friction, it's n times mu, which is 5 by 0.25, which is 1.25. So from here we can use the normal equation. Normally it would be T equals the mass times omega squared times r, but since friction is the one which is preventing it from slipping and not tension, we put friction equals mass omega squared r. 1.25 is 0.5, omega squared 0.1. You'll get omega to be 4.95. For number 5, you have a particle of mass 0.5 kilogram. It is attached to a light inextensible string of length 25 centimeter, which is 0.25 meter. That is attached to a point O, and it moves in a horizontal circle. They also gave you the speed v, 2 meters per second, and they want you to find the tension. So from here you do T equals m v squared over r. The mass they gave you, the mass is 0.5. The v squared, it's 2 squared, and you have this 0.25. You will get 8 Newton. Now for part B, you have a mass of 250 grams, which is 0.25 kilogram. It is attached to like a light elastic string. They gave us the modulus 5 Newton and the natural length L0 75 centimeter. They also gave us the final L 100 centimeter, and they want you to find the constant speed v. It also moves in a horizontal circle. So you do like before, t equals m v squared over r, but in this case it's lambda over L0, L minus L0, which is 5 over 0.75 into 1 minus 0.75. You will get 1.7, and then you put 1.7, it's equal to 0.25 times what you want to find is v squared, and you have the radius is the same, or no, actually when it's rotating the string is at full length, so you put it as the final length, which is 1 meter. You will get v to be 2.61 meters per second. For number 6, part A, you have a mass of 200 gram. It's attached to one end of a light inextensible string. The length is 0.5 centimeter, and it's fixed to a point O. It moves in a horizontal circle. They gave you the tangent 2.5. They want you to find the speed. So you just substitute in the equation t equals m v squared over r 2.5. It is equal to 0.2. 0.2 times v squared over the radius, which is 0.5. You will get v to be 2.5. For number 6, part B, you have a wooden hoop and you have a bead inside of mass 200 gram, which is 0.2 kilogram, and the radius of this hoop is 100 centimeter, which is 1 meter, and you also have the speed of this bead. The speed is 6 meters per second, and this is moving in a horizontal circle like this with the inner surface of the hoop, and they want you to find the magnitude of the reaction. So what you do is net fx, or net f only, is m v squared over r. So we got m to be 0.2, it's given 6 squared, and 1.0. You will get 7.2. So the magnitude of the reaction is 7.2.
Number 7, a particle P of mass 500 gram rests on a rough horizontal disk. So you have a disk here that's on a table and it's spinning, and you have a particle on it supported by normal push and friction. It's rotating at uniform speed. So you have UCM with the friction giving the push towards the center. the centripetal acceleration push. So mass 500 grams, distance 25 centimeters, angular speed. So first thing that should come to mind is force is equal to mass times acceleration of this is normal. So F is the friction. So friction is mu mg is equal to m, and then A is v squared over r, or omega squared r. So mu is, you need to find it, so x, or actually just keep it mu, m and m cancel. So mu is equal to omega squared, so 5 squared times 0.25, you have to change this to meter, over g, which is 9.8 or 10. Hopefully they give it to you in the exam, and you put in the calculator and you get it. Number 8. A particle P of mass 200 grams attached to one end of a light string, and you have all the given. It's basically just a rope. It's a rope on a table moving in a circle. Given the speed is 10, calculate radius of circle. So since it's elastic, you know that you have to use the formula for tension using the modulus. So 20 over natural L 0.5 into X or R or L minus 0.5. This is tension is equal to MA. So M, so 0.2, and then A, which is omega V squared over R. 10 squared over R. See, so now you have one variable and you can just plug it into your calculator and find it, or do algebra. So number 9. First you need to understand what's going on here. You have a point C and you have two strings pulling it, and as it's spinning it's exerting a tension force whose resultant will be here towards the center, such that it gives it a centripetal acceleration. So let's try. So this force and this force, each of the angle that makes here with alpha, so the resultant here, T net or F net, is equal to 2, and then tension over cosine alpha. Now here this is 1, here it's 0.8, and then Pythagorean 0.6. So cosine alpha is 0.6. So T net is equal to 2 over 0.6, or 20 over 6 of tension in each. So T net, not net, sorry, but the Y resolved. So 20 over 6 T is equal to the force, net force, for the centripetal acceleration, which is m omega squared r. M is 0.2, omega is 10 from the given, and then r. R is the distance here, and Pythagorean, you get 0.6. So then you just resolve it, and then you get 12 here, 6 goes up, 12, 6, 2. Put in your calculator, you'll get the answer. As you see here, done. Next one. 10. Particle M, it's attached to the light elastic string. Other end is fixed, moves in a circle. Just a typical question, not like the other one. So, tension is equal to MA. But tension is elastic. The string is elastic. So you need another formula. It's modulus over L0 into L minus L0 equals to M, and then A is centripetal. So it will be omega squared R or V squared over R. So find the constant speed, so we'll use V squared over R. So we have this one. Now let's fill in values. Modulus 5 mg over L0 into radius 6L over 5. So 6 over 5 L0 minus L0, which is 1 over 5 L0, is equal to mv squared over 6 over 5 L0. This is r, so radius. Now, just some simplification. M cancels, and then here you get 1 over 5 L0, so the 5 cancels, and then you can move the L0 here up. So the L0 here and the L0 here cancel. So then you'll end up with, I know it's a bit hard because I made it hard. Sorry, just cancel 1 over 5 L0 cancels, and the 6 over 5 L0 is brought up. So 6 over 5 L0 G is equal to V squared. So V is the square root of that. 11, you have a light rod. Oh, and you have a mass at A, you have a mass at B. This one is 2L, so 3L. So what's happening here is it's rotating around O, and therefore you have centripetal force. So at B it's here, and at A it's here. So at this portion, which is AB, there is only one force contributing to the tension, and that's the centripetal at B. But at OA, there is another force at A. So A force, you have FA plus the one at FB. So FA has to be stronger than usual to support the tension. So FA minus FB is equal to whatever the net would be at A for centripetal. So let's start. Magnitude of centripetal A, it's just this one straightforward. So you have FB, which is equal to MB omega squared RB. M is 4M, R is 5L. So this would be equal to 20 M omega squared L. Next one, magnitude of FA. So what I did from before, FA minus FB is equal to the formula. So MA omega squared RA. So it is equal to M3M omega squared 2L. So 3 and 2, so 6 these constants. So 6 and then plus FB, which is 20, so 26 omega squared ml for B. Then calculate the ratio of the magnitudes of tension. Obviously it's OA, AB, you got the AB, you got the OA, so it's just 20 over 26. Let's check if it's correct. Yep, or 26 over 20. Just make sure that's FA over FB. And that's it for part 2. Mechanics part 3, number 1. So uniform lamina is bounded by the curve, and then you have to find the center of mass of the area. Here, to find the x-coordinate, you have a formula. To find the y-coordinate, you have another formula. It's right here. If you want, you can take note of it and then use it for the exam. So x-coordinate, it's x into f of x over f of x, obviously dx in integral. So f of x is y, and since you have y squared, you just square root it. So y is equal to square root of 4x, which is 2 square root of x. So use that formula. So integral a and b is, if you can imagine the curve, it's like this. So x-axis, the area between this curve, x-axis, and line x equals 1. So this was 1, this is the area. So the limits, or the boundary, is from this intersection to this intersection. So 0 to 1. So from 0 to 1, x, f of x, so 2 root x, dx over integral 0 to 1 2 root x dx. I'm going to put that in the calculator or solve it like we did in math, and you get the answer over there, 0.6. Find the y coordinate. It's another formula, this one right here. So from the graph we do a 0 to 1 of f of x squared, and you already have the y squared here, so just put 4x dx over 2 integral 0 to 1 2 root x dx, and then put in the calculator and solve, or do it like we did in math, and you get 0.75. Next one, I'm going over some relevant ones. The others are just derivation or similar to that one. So find the coordinates of the center of mass of the solid formed when the finite region is bounded by the curve. So y equals x squared. So x squared is like this. The line x equals 1 and the x-axis. So here, if this was 1, then this solid, this area, is rotated 360 degrees from the x-axis. So here again you have another formula noted down here. So what's the boundaries? From the what we drew, it was like this, and then here. So it was from 0 over here. That's a bad drawing. Like that. 1. So here it was from 0 to 1. So that's saying boundaries. So integral 0 to 1 here, x into f of x squared. So x squared, and let's square that, dx over integral 0 to 1 x squared, and then that squared dx. And when you solve it mathematically, you get 5 over 6. So this is a formula you should know for the exam. Now the next one is this, deals with the center of mass. So you should know there are a couple of, again, formulas, or you can derive them. Here you have a cone. The center of mass is 1 over 4 from the base. So it will be 3 over 4 from the point of origin. So 3 over 4h. That's where the center of mass is. And then it's all along the y-axis, x-axis, so the y value is 0. And then here you have a cylinder. And since it's symmetrical, you just take the middle. So here it will be h plus, because you have this whole value here, plus the middle, so L over 2. But you know that L is equal to h. So now you have 3 over 2 h. And given that height is 8. So h is, so the center of mass, the x value for the cylinder is 3 over 2 times 8, which is 12. So to get the coordinate of the center of mass of the whole body, you have a formula, mx plus mx over m plus m. Obviously it's m1 x1, m2 x2, m1 m2. So how do you get the m? You know it's given that it's the same density. So it's sort of like you're playing with the density times volume. If you don't have the same density, then they should give you like, it's 3 times the density, then you multiply by 3 sigma instead of sigma. So the volume of the cone is 1 over 3 pi, and then r squared, which is 3, so 3 squared, and then h, which is 8, times sigma, because density, and then times the x value, which is 3 over 4 times 8, which is 6. Now plus the cylinder, so pi r squared times height, so pi times 3 squared times height, which is 8. And then that's the volume times density, you get the mass, multiplied by the center of mass at x value, which is h, which is 8, and plus L over 2, which is 4. So 8 over 2 is 4. So you get 12. So times 12 over total mass, which is 1 over 3 pi 3 squared 8 sigma plus here pi 3 squared times 8 sigma. And when you simplify it, cancel the sigma, then you're left with no variables and just constants. You plug into your calculator and you solve. And that's everything for that question. This one. So we took the addition of center of masses. Now here's the subtraction when you remove an object. So R1 is 4. So this one is 4. And the small one is 3. So it's half of that. And then here, for the y value, you have that. It was 6 whole thing. And then the smaller one is 3. So the dimensions are halved for the length and height. So the mass of the large one is pi r squared times height times density. So pi, and then r is 4 times height, which is 6, and then density. Now we use the formula mx plus mx over m plus m. So that's m. What's the x value? It's directly half. So 6. So the y value is always at 0 because it's symmetrical, up or down, same thing. So you just take the half for finding the x value. So this is 6. So the middle is 3. So times 3 plus the smaller one. Well, not plus, sorry, minus. You see, because you're removing it. Minus, what's the mass you took away? It's pi r squared times height, but r is 2 squared times height, which is 3, sigma, and then the x value, which is half again. So this whole thing is 3, so it will be 1.5 times 1.5, and then over mass minus mass. So pi 4 squared times 6 sigma minus pi 2 squared times 3 sigma. And sigma cancels. These are just numbers. You put in your calculator, you get it. And that is it for that question. So the ones I'm doing are just the ones that are important or need recognition. Here it's a similar value. What you do is just mass minus mass. And then over here you are given this one, cone, and you have to measure the altitude from G to BV, and you have to know if this one is less than or greater than, if BC is greater than, less than, or GH. If it's less than, then it topples. If it's greater than, you're safe. If it's at that point, you're safe. For safe, it is stable. And you find GH by using this triangle, and you find VC or BC by using that triangle. And this one. A uniform solid hemisphere of radius r, suspended by a string, attached to a point on the rim of its base, as shown in the figure. Find the distance OG in terms of r. So, what do you know about OG? It's 3 over 8 r. So 3 over 8 r. This is a formula that we derived in physics class. So 3 over 8 r is, this is 3 and this would be 8. And you just have to have it in terms of r. So this 3 over 8 r. Now OA is r itself. And then that angle set up, it's similar to the one here. It's the same value, the measure. Now what you need to find is tan alpha. And how do you know that this line of action, it's directly at G, or the AG is that point itself? It's because it always passes through the center of mass, so that it won't have any torque and it will just remain down. So now you have the triangle and they want tan alpha. So tan is opposite over adjacent. Now if you look here, alpha, the opposite is r, over adjacent, which is 3 over 8r. Now flip it, or you don't flip it, you just simplify it. R and R cancels, 3 over 8 is in the denominator, you move it up, so you get 8 over 3, and that's tan alpha. And then to get alpha, you do tan inverse of, in your calculator. Square lamina, again, you just do density times area or volume, but it's area in this case. And then you're removing the semicircle, so times the x or y value minus the density of the area of the semicircle times the x or y value of the semicircle over sigma a minus sigma a. This is the square, this is the semicircle, when you get it. And that's pretty much the basics. Here we took it like last time, it's just putting the same formula again and again. Although to understand, you need to understand how do you get the center of mass, which is mostly what I told you. 3 over 8 is for the hemisphere, and anything else that comes up, they should give it to you, or it's simple knowledge. So like if you have a cylinder, it's half of it. Or if you have something symmetrical, it's half. If you have a cone, it's 1 over 4. Now here, a uniform ladder of mass 10 kilograms rests against. So this is just FBD. We took it in mechanics last year. This is G, 100 newtons. And smooth vertical wall. So this is the only one. And then here you have another normal push. And then here you have friction. Like that. So what did they ask you? Calculate magnitude of the normal contact at the wall. So what you do is you take this point as your reference. That way you don't have to worry about the two forces. Now the torque is equal because you're at what do you call it? You're at equilibrium. So 100, which is the weight, times this value, which is half of r cosine. So half of r, because you have this is half of r, and then cosine is because you want the adjacent. Cosine alpha is equal to x, and then you have, if you look here now, this whole thing is r or L, and then this is alpha, so you want sine alpha. So r sine alpha, and the r and r cancel, and then you'll get x in terms of tangent alpha, and you have alpha to be 60, so you just substitute. Now that you have the x, so you have this is the x, you have this is the x, and you have this is the y, you have this is the y. So they're all like in a 90-degree frame. So you just equate them to each other, because it has one force here, one force here. So you got normal contact, it's equal to the friction over here. And you have the weight, and since it's the only y value, the normal push here is similar to the weight. Obtain the least possible value. Well, it's normal push times mu equals F. So the answer you got for C, or A, you equate it to mu, and then mg, and it should simplify nicely, such as here. Well, it doesn't simplify nicely, but you get a value. And that's pretty much it for part 3, or whatever is going to come in the exam. So good luck.